Hello everyone, welcome to today's class. It is me, Teacher Simon, again taking you through Cambridge International AS and A-Level Mathematics Paper 4.3 for October-November 2024. This is part 1 for questions 1 to 4. Question 1. An athlete has mass m kilograms. The athlete runs along a horizontal road against a constant resistance force of magnitude 24 newtons. The total work done by the athlete in increasing his speed from 5 meters per second to 6 meters per second while running a distance of 50 meters is 1541 joules. Find the value of m. Using my sketch here, I can have, this is the athlete, maybe moving up to here. And at this point, the speed is 6 meters per second. Then here it is 5 meters per second. Then this distance here is 5 meters. Of course, there is a resistance force here, 24 newtons. I can use the energy method, okay? There are two methods you can use here. So using the work energy principle, work done by the driving force, work done by the driving force minus work done against resistance, work done against resistance, then is equal to the change in mechanical energy. The change in mechanical energy. You are pushing this particle forward. As you are pushing it, you are doing work because you are applying that force, okay? Then there is resistance force, which is also opposing your motion. You see, that's why we say work done by the driving force, then minus work done against resistance, then is equal to the change in mechanical energy. Mechanical energy is the sum of potential energy and kinetic energy. Okay, potential energy is mgh, that is if we have vertical height. Okay, and then this one, kinetic energy, is a half mv squared. Okay, now this, since this one is moving on a horizontal ground, we don't have the vertical height, so the change in mechanical energy is going to be due to the change in kinetic energy. Now they say that the total work done by the athlete in increasing his speed from 5 to 6 is 1541. So that is the work done. That is the driving force. Okay, so 1541. Then minus work is force times the distance. Okay, the force is the resistance force. We are having it as 24 times the distance, 50. Then this one is going to be equal to change in mechanical energy. We are going to say final mechanical energy, so a half m, then times 6 squared, minus the initial, a half times m, then the initial speed is 5 squared. So if we get our calculator here, 1541 minus 24 times 50, this one gives us 341, so I'll write here 341. Then this other side, 6 squared is 36 divided by 2, this will be 18m, and then minus 25 over 2m. So if we get 18 minus 25 out of 2, then this one gives us 5.5m. So I write here 5.5m, then is equal to 341. So meaning m is going to be 341 divided by 5.5. So what do we get? 341 divided by 5.5. It gives us 62. So the mass of the authority is 62 kilograms. M is equal to 62 kilograms. That is our answer. That is the first method. Alternatively, I can use the F is equal to MA. Okay. First of all, let me put an alternative approach. Alternatively, we know that work done by the driving force is given. So work done by the driving force is going to be equal to that driving force, then times the distance. Okay. So it is given as 1541, then which is equal to the driving force, then times 50. Actually, let me add here the driving force. There is a driving force here. Okay. Then what will be our driving force? So the driving force is going to be equal to 1541 divided by 50. 1541 divided by 50. So what do we get when we 1541 divided by 50? That one gives us 30.82. 30.82 newtons. I keep that. Now using V squared is equal to U squared plus 2AS. Final velocity is 6. Then the initial is 5. So what will then be the acceleration? We don't know it. The distance traveled is 50. So that means here we shall have 36 minus the 25. Then we shall divide by 100. Because 2 times 50 is 100. So that will be A. Then here we shall have 11 divided by 100. That is 0.11 meters per second squared. That's the acceleration there. Now, using F, which is equal to MA. So we have the driving force minus the resistance force, then will give us the MA. The driving force is 30.82 minus the resistance force is 24. Then this one will be equal to the mass is M, and then acceleration is 0.11. So we have that. So that therefore implies that our M is going to be that 30.82, subtract the 24. Then we divide by 0.11. Does it give us the same answer? Let's check. 30.82 minus 24. Then divide by 0.11. So this one is also giving us 62. So either way, you get the answer. Question 2. Coplanar forces of magnitudes 16 newtons, 12 newtons, 24 newtons, and 8 newtons act at a point in the directions shown in the diagram. Find the magnitude and direction of the single additional force acting at the same point, which will produce equilibrium. Now that means these forces are not in equilibrium. So there is that additional force. Probably I'm supposed to add it here, or here, or here, or here, even these ones here. So where are we going to put that force? Now what we can do here is to just find the resultant of these forces, okay, and then we reverse its direction. For example, if the resultant force is here, okay, this is the resultant force, and it is acting in this direction, so it is below this with a certain angle, then we put it this other side, okay, and then after putting it this other side at the same opposite angle here, so that will be the force that we put here, such that it becomes the system goes to equilibrium. So that is that. So we just find the resultant of these forces. Now we resolve the forces. Remember, this one can be like this. Maybe this is the 12 here is our hypotenuse. Then actually let's consider this one here. This is 30. So if that is 30, then this is the opposite. So we shall use sign there. Then this is the adjacent here. So usually what I say without wasting time is closing in. So you are supposed to resolve all of these forces vertically and horizontally. So closing in is cosine. Okay, then opening is cosine. I mean sine. Then here I will be closing this angle. Here I will be opening it up. Here I will be closing. Here I will be opening it up. Okay, so I always draw everything on one diagram. So I can put my axis here. When we check here, there is 24 here, newtons. Now, resolve this one here. We shall get 8 cos of 30. That means this way, it will be 8. Here we shall have 8 sine of 30. Okay? Then, this one here, close it here. We shall have 12 cos 30. Then bring it down here, open it up. This will be 12 sine 30. See that? Then close this one here. You will have 16 cos 30. Then open it up here. Then it will be 16 sine 30. So those will be our forces. Now we are supposed to find the resultant of these forces. So resolving the resultant force, actually, let me just put, if we put our calculator here, we put in, let's say, the horizontal forces here, 16 cos 30. Okay, is it bigger than the other ones? This is 8 root 3, which is 13 point, let's say 9. Then the other one is 8 cos 30, 8 cos 30, then plus 12 sine 30, 12 sine 30, then plus the 24. So this one is far bigger than the other one. So that means the resultant in the x is going this other direction. Okay, let's check for the resultant in the y. 12 cos 30. 12 cos 30 is giving us 6 root 3, which is 10.4. How about these ones going down? 8 sine 30, then plus 16 sine 30. Okay, this one is giving us 12. Remember, the other one was giving us 10 point something. So that means the one going down, these ones going down are bigger than the one going up. So these ones are bigger, so we shall have the resultant in y going down. Now, having realized that, okay, let me just put our resultant in y will go down, our resultant in x will go that side. Now, the resultant of the forces, I can write it here like this. Resultant of the forces is going to be, let me write it as a vector. So we can have 8 cos 30, then plus 12 sine 30, then plus 24. Okay, then we shall subtract 16 cos 30 degrees. Okay, then that is the resultant in the x. Then the resultant in the y, it is going down, so we shall have 16 sine 30, then plus 8 sine 30 degrees, and then we subtract now the 12 cos 30. Okay, so our resultant of the forces is now going to be, in fact, let me also represent it here. So I'll have something like that, and then here like that. Okay, have the resultant in the y there. So this is Rx, this is my Ry, and then the resultant is going to be here, the resultant force. Then this one here, I will now produce it here. Okay, same angle here. Opposite angles are always equal, so this angle will be equal to this angle here. So the required force will be now here, same as the resultant. Then I change the direction here. Okay, let me even make this one a little bit dotted, just like that. So putting everything in the calculator, our Rx is going to be, we have 8 cos 30 plus 12 sine 30, then plus 24 minus 16 cos 30. So we get 30 minus 4 root 3, 30 minus 4 root 3. And then I also go to Ry. My Ry is going to be 16 sine 30, because that will be 8, then plus 8 sine 30, that will be 4, then minus 12 cos 30, that will be 6 root 3, and then we get 12 minus 6 root 3. So I'll have here 12 minus 6 root 3. Then from there, now to get the resultant of the forces, the magnitude of the resultant of the forces. In fact, this one is like a vector like that, so let me just put it like that. So now the resultant here is going to be the square root of this Rx, n squared, then plus this Ry squared, because these ones form a right angled triangle. Okay, so we use SOHCAHTOA. You see, so I can produce this one onto this. So the Ry, then I can put it here, Ry. So I have Rx going this way and then Ry. So they form 90 degrees. So you can see that this is the hypotenuse there. All right. Then from there, I can just put each and everything in the calculator here. We are going to put the square root of 30 minus 4 root 3, then bracket squared plus 12 into, 12 minus 6 root 3 squared. Then that is 23.1. So I'm just going to take to 3 significant figures. This one is going to be 23.1 newtons. Okay, then let's find now the direction. So this one is to a certain angle here, this one here. That is the one we want to find. Now we are going to have tan theta, because this is opposite over adjacent, so we shall use tan theta. Tan theta is equal to the opposite, the Ry, which is 12 minus 6 root 3, then divide by the Rx, which is 30 minus 4 root 3. So theta will then be the arctan of this 12 minus 6 root 3 out of 30 minus 4 root of 3. So putting this in the calculator, we are now going to have the arctan of 12 minus 6 root 3. Then down we have 30 minus 4 root 3. So putting all of this here, we shall get our answer as 3.98, and the rest of that, but the 3 significant figures, I will have 3.99. This will be 3.99. Then this is the one that I will put here, the 3.99. Okay, 3.99. Then I can conclude and say the force is 23.1 newtons above the negative This is now its direction above the negative x-axis. Okay, if we had a force there, just like we have 24 here, okay, suppose I had a force here, let's say 50 newtons, I would have said above the 50 Newton force, okay, but we don't have any, I just say above the negative x-axis. Question 3, a car of mass 1,600 kilograms travels up a slope inclined at an angle of arc sine of 0.08 to the horizontal. There is a constant resistance of magnitude 240 newtons acting on the car. Part A, it is given that the car travels at a constant speed of 32 meters per second. Then they are saying find the power of the engine. Okay, you should know that for constant speed, acceleration is always 0. Again, I'm going to do some sketching here. This is the car, which is on an inclined plane. It is going up, so there is a driving force, and then there is resistance, which is 240 newtons. There is also mg sine theta. We can also include it there. There's an angle here. Then from there, we can now have, so using our F, which is equal to ma, we can have the driving force minus the 240 minus the mg, so m is 1600, g is 10, then sine of theta is 0.08, which is equal to 0. That means the driving force is now going to be equal to the 240, then plus 16000 times the 0.08. So what does it give us? We shall have 240 plus 16000 times 0.08. So this one gives us 1520 newtons. Now power is the rate of doing work, okay? So if power is the rate of doing work and work is force times distance, of course we shall divide by time. Now distance over time is speed. So we can say the driving force now times the velocity. So the driving force is 1520 times the velocity, which is 32. So which power do we get? Times 32, this one gives us 48640. 48640 watts. So in kilowatts, then this one we shall divide it by 1000 and we write 48.64. That's if they asked for the answer in kilowatts. Part B, find the acceleration of the car when its speed is 24 meters per second and the engine is working at 95% of the power found in A. Now we need to find the new driving force. Remember, power depends on the driving force and the speed, you see. So the new driving force is now going to be equal to, they say 95%, that is the same as 0.95 times the power we have gotten for 8640. Remember, the driving force from here is going to be power over the velocity, okay? So this is the new power, 0.95 times 48640. Then we divide by the speed, which they have given us as 24. So what I've gotten here, I can multiply it by 0.95, then I divide by 24. And this is a recurring decimal. So I just leave it exact, 5776 over 3. That is newtons. Okay, now again, I'm going to use F is equal to ma. Using F is equal to ma. So our driving force minus the resistance force, then minus the mg sine theta, okay, is equal to ma. Remember, we're still using this diagram here. Then from here, our driving force is 5776 over 3 minus the 240 minus the mass is 1600. The G is 10, sine is 0.08. Then I can divide everything by the mass. This particle, that is 1600, this one will give us the acceleration. Then I can put everything here. Okay, so we have 5776, then over 3, then we say minus 240 minus 16000 multiplied by 0.08. Then down we have 1600. So it is 19 out of 75. It's not a terminating decimal, it is a recurring decimal. So I just write 19 over 75. These exact answers are really much more perfect than the rounded figures. I can leave it just like that. Number 4. Two particles A and B of masses 3 kilograms and 6 kilograms respectively lie on a smooth horizontal plane. Initially, B is at rest and A is moving towards B with speed 8 meters per second. After A and B collide, A moves with speed 2 meters per second. Find the greater of the two possible total losses of kinetic energy due to collision. When A, which is lighter, okay, collides with B, which is heavier, it can continue to move forward or it rebounds. Okay, let me write that statement here. When A, it is lighter, okay, collides with B, which is heavier, it can either move forward or it rebounds, And we are going to use the principle of conservation of momentum, where the momentum before collision is equal to the momentum after collision. So MAUA plus MBUB then is equal to MAVA plus MBVB. Okay, that is the momentum after collision. Now, let's consider this particle moving forward, okay? As we are considering two scenarios here. It is moving forward and also when it is moving backward. So this one is going to be here for backward movement. Okay, backward movement. So for forward movement, we are going to have 3 times 8, then plus, of course, 6 times 0. Then this one will be equal to 3. A moves with a speed of 2. So the mass is 3, then times 2, and then plus 6, then VB. It is moving forward, so they are moving in the same direction. That's why I'm taking all the velocity is positive. So this is 18, then I can divide by, I can subtract 6, then after I divide by 6. So, 3 times 8 is 24, then I'll subtract 3 times 2, that is 6. That one will give us 18. Then when you divide by 3, that means the velocity of B is going to be 3 meters per second. Okay, and then for backward, we have 3 times 8, then of course plus 6 times 0. Then since A moves now backwards, that means its velocity here is a negative. It's moving in the opposite direction. Then 6 times VB here. So here we have 24. Then we shall add 6. then we shall divide by 6 to get VB, and then the VB here is going to be equal to 5 meters per second. Now, they talked about the question is about to find the greater of the two possible total losses in kinetic energy. So we need to get the total, the loss in kinetic energy due to the backward movement of A after collision. And also we look at the loss in kinetic energy due to the forward movement of particle A. Okay, so here I'm going to look at these two here. Final kinetic energy. Final kinetic energy. Okay, after collision. When A is moving forward. Okay, when A is moving forward. So this one is a half, then times 3 times 2 squared. This is for A. Okay, the final is 2. So that's why I'm putting a half. Remember, kinetic energy is a half mv squared. Okay, then for B, it's a half times 6 times A is moving forward. So when A is moving forward, for B, it is going to be 3. Okay, 3 squared. So here we shall have 6, and then here we shall have 27. So this one will give us 33 joules. Then let's look at the final kinetic energy. The final kinetic energy after collision. When A is moving backward. Okay, when A rebounds. So this one is going to be a half. Then the M for A is 3, and then the speed is 2, then plus a half. And times, this is now for B, 6, then times 5. Okay, squared. And since this is final now, I can even put it as a minus, like that. And then this one can give us 6 here, and then 25 times 3, that is 75. So when we add, this one will give us 81. Okay, then let's look at the initial kinetic energy. The initial kinetic energy. So this one is before collision. Here. So since B was at rest and it was only A moving, that means the kinetic energy is due to the movement of A. So A is moving towards B with a speed of 8. So I will have a half here times the mass of A, which is 3, times then the velocity at which it was projected, it's 8, then 64 divided by 2, you get 32 times 3, that will be 96 joules. Now, I'm supposed to get this 96, and then I subtract this 81, or 96 minus 33, and then we get, they said, the greater of the two. So the greater of the two has to be the greater loss in kinetic energy. Kinetic energy is when A moves forward. When A moves forward. Okay, because you can see that 96 is far away from the 33 than this 81. So when we subtract these ones, we shall get 63 joules. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.